Welcome back, everyone. We're going to continue with the homes data set here. Now that we know what lambda is, what I want to do is to combine the zip code, the city, and state columns into a single new column. And we'll call it zip city. So let's do that. And we're going to use lambda for this. So I'm going to say DC metro df. And to create the column, you just put it in here. So this creates the column. And you just have to tell it what's going to go in it. Now what I'm going to do is I'm going to DC metro df, double square bracket. So I'm going to take zip city. I'm going to take city and state. And we're going to apply this lambda function, lambda x colon, and we're going to do hyphen dot. We're going to call it the join method, join x, and this is for column, so we say axis equals 1. So let's understand what's going on here. For the moment, I'm just going to put this on a new line just so it's a little bit clear, so I can talk about the whole thing as without having to scroll back and forth. So we're taking this inner list that we have, zip city, city, and state. Lambda is calling this x parameter. X initially becomes zip city, then appends the hyphen using join x because it is a column, and then x becomes city, and then another hyphen, and then x becomes state, and another hyphen. So this is a very convenient, cool, professional way of doing this, of course. However, I do want to point out that if you wanted to, you could. There is another way which might make more sense to you guys. So I can say DC metro df zip code. I can say as type string plus a hyphen plus DC metro df city, again as type string. So basically it's just a concatenation that we're doing, plus DC metro state as type string. So if this makes more sense to you, simply concatenating them together, that's perfectly fine. I just wanted to take this moment and also show you what lambda is, because you're going to see that in various code and what it can be used for. Let's actually do a shift enter, and I got an error message. Wonderful. Where did I make a mistake here? Let's check it out. All right. Usually the last line, zip city is not an index. Okay. Of course it's not an index. I'm creating it. So DC metro zip city equals DC metro df. Oops, I put zip city here. This is supposed to be zip code. That's where I made a mistake. Let's do shift enter, and we're good to go. Let's take a look at DC metro.head. And we should have this new column, except it always adds it to the very end. So if I scroll all the way to the end, you can see there is zip city. Of course, that is kind of inconvenient that it's all the way at the very end. I am going to take a look at it this way too, by calling columns and values. As we saw earlier, you can see that it shows up at the very end. So we'd like to actually move this to the front. So I'm going to reorder columns so that zip city, what we just created, is the first column. So let's see how we can do this. Pretty cool. So first I'm going to create a calls variable. I'm going to take DC metro df dot columns dot values dot to list. So this is going to take these columns and turn them into a list, a Python list. And we know that we have a Python list. We can manipulate it with our slicing methods fairly easily. So I'm going to now rearrange the columns. We can see that column we want is the very last one. So I'm going to let calls be equal to calls. And recall that whatever is on the right-hand side of the assignment operator gets executed first. So I'm going to say -1 colon plus calls colon -1. And let's take a look at calls now. And you can see that that moved the zip city to the very first position, which is what I wanted. Of course, this is just the list. We have not in any way impacted the original data frame. What we like to do is to tell the original data frame now that this is the new form, the new column order. So change the column order in the data frame. So DC Metro DF is going to be equal to DC Metro DF calls. So the columns are going to be rearranged by this, and let's take a look at DC Metro DF head, and voila, we have zip city sitting as the first column, which is what we wanted. You can see how cool it is to go move back and forth between pandas and Python. Pandas, of course, is a Python library, but we can do this all day long and get things done very quickly with very few lines of code, which is very cool. I want to do a little test here, some testing. So I'm going to say test is equal to data.log data. This is the original data frame. This is not the DC one. Is double equal to Washington. And let's take a look at test. And we can see that all the Washington metro area, etc., showed up. Let's actually take a look at test and set this equal to itself dot lock, and I'm going to take state, which is this field that I want, and I'm going to set this equal to well, let me do lock and then put test state in here. Oops. Because I want to do another comparison. Double equals, let's say, Virginia. Okay, and let's take a look at test now. And you can see that I filtered out all the Virginias this time. So by doing this little comparison up here, using the lock to locate what we're after, we're doing a comparison in here. Just basically do a slicing of all the Virginia states. So this is going to come in handy for us in just a moment. And that's what I wanted you to see. First, let's go ahead and take a look at exploring the size rank column. So I'm going to take DC Metro, and this is for the DC Metro that we're doing, and I'm going to call the sort values method. You recall this allows you to sort stuff. What do you want to sort by? I want to sort by size rank. And ascending is equal to false. And let's just take a look at the first 20. Brings up as some interesting stuff right here. The size rank is showing up because we said order by size rank and ascending equals false. The largest size ranks show up. But the reason I'm doing this is for you to understand that you also need to read the results carefully and properly. A size rank of 12,622 is a large number. But remember, New York was size rank 1. So what this says is that this is probably an area where the population is very, very low. And it happens to be in Virginia. You may recall we had 12,777 rows, and this one is sitting at 12,622. So this is near the bottom. It's in a place called Summer Duck in Fauquier County. And so point being that just because the size rank, the name says size and rank is in it, it may seem like, wow, this must be, big. It's not. In fact, it's the opposite. So reading the results correctly is important. I just wanted to point that out. We don't really need this size rank column, so I'm going to drop the size rank column. Let's not even worry about it. So DC Metro df.drop. Recall that when you drop, you put in what it is you want to drop, and you have to say axis equals 1 to let you know that it is a column. Remember, the 1 looks like a column. Now, if I just do this isn't good enough because this doesn't change the data frame. It just, drops it temporarily. We can set this equal to itself, which we've done in the past. I can say DC Metro is equal to that, and that would work. But there's another way of doing it, which is to use the in place equals true property. So this also works, and I like this better whenever I can use it. So let's take a look at the head, and we get this little warning, but it did work out. And this is what I wanted you to see, that I don't want to see these warnings. I do not want to see these warnings. So what I can do is I can go back up to when we had our warnings, import warnings. You may remember I said import warnings. And one of the things I'm going to do is to say warnings dot filter warnings ignore. And by doing this, and I'm going to do a shift enter, so that is taken care of too. By doing this, then we will no longer get these warnings, which might, make people upset. All right. So I can't, unfortunately, I just deleted the size rank, so it's no longer there. So that's the reason that I'm getting this error message. What I can do is I can go back and basically just go to cells and say run all again. And by doing that, it will recreate everything, and everything will be nice and peachy. And you can see that I did not get an error message at this point. So, or the warning message, I should say, not an error message. So I just wanted you to see what that warning was all about, in case you were wondering what did he import that thing for. That was the reason. Okay, so we have this. Let's go ahead and make sure that only DC, that's Washington DC area zip codes, are in the DC Metro DF. It seems fairly clear so far that it seems like all these are Washington DC metro regions or names. But could it be another place in the country that has the name Washington for its metro region? And that's what we want to basically check. So I'm going to take DC Metro, and this is pretty cool. Take a look. I'm going to take the states, and I'm going to call the unique method. And take a look at it. And it returns Virginia, Maryland, DC, Indiana, and West Virginia. I suppose West Virginia is a stretch, but it is, it could technically, parts of it could be considered part of the Washington metro area, but Indiana is just way out there. It is way out there. So we can see that we have data that we really don't want to have. So let's go ahead and drop the Indiana values. So DC Metro DF dot locate. I'm going to locate in the original data frame the state where it's equal to Indiana. And I can see that I have two metro areas called Washington that happen to be in the state of Indiana. I don't want these guys, so let me go ahead and drop them. I can say DC Metro DF is equal to DC Metro DF dot drop. And what I want to drop is this 51, 96, and 99, 69. I want to drop these. Now remember, these are rows that I'm dropping. These are rows. Normally we have columns here that we drop and stuff like we did with size rank, but these are rows. So we're not going to put axis equals ones here. So rows, so we do not need axis equals 1. Okay, guys, let's go ahead and shift enter, and let's check out the DC metro.df and state.unique like we did before. And we can see that Indiana was in fact removed from our DC metro data frame, which is very cool. Great. So I'm going to stop right here and do the rest of it in another video or possibly two. Thank you again for being a great audience. As always, if you're enjoying these, please feel free to share them with friends and loved ones. I'll see you in the next video.